We are going to do our math workshop first. We're going to do 5 through 8 today. Go ahead and make sure you've got a calculator, make sure it works, make sure you have a math workshop, and make sure you got a pencil, okay? I'll give y'all just a second to get everything ready. Alright, if y'all need more time, y'all know what to do. Just pause the video and we'll go from there, okay? Alright, number 5, you've got 64. Alright, well, 64 is not a perfect fourth, but remember how to get perfect fourths. It's 1 to the fourth is 1. 2 to the fourth is 16. 3 to the fourth is 81. So obviously 64 is not on that list, but 16 divides into 64. So if you take your calculator and divide that, then you will get 4. Okay, and since it's an even root, we're going to put plus and minus 4. Alright, remember then your letters have to divide by that 4 that's out front. So 15 doesn't divide by 4, but 12 does. Then you got to have 3 more to make 15. Alright, 6 doesn't divide by 4, but 4 does. Then you got to have 2 more of them to make 6. Alright, so I'm going to divide this guy by 4 and this guy by 4. Alright, so I get plus and minus 4a to the third, b to the first, which you don't have to write the 1, but you do have to make sure you write that 4 on your root, and you get a to the third, b to the second inside the radical. And that's it. Alright, number 6, 7, and 8. So unfortunately, I did not fix these on the math workshop, and I made copies before I realized it. So take a second and rewrite 6, 7, and 8, okay? Alright, if you need an extra minute, just make sure you pause the video, okay? Alright, number 6, you're adding logarithms together. So to put them as one logarithm, you're going to multiply them. Alright, and so you do not have logs on both sides. So you do the little swoosh thingy, whatever you want to call it. Alright, 6 is your base, 2 is your power, and x times x minus 9 is what it now equals. So then 6 squared is 36. Distribute the x. Alright, since you have an exponent of 2, you're going to move that 36 over so that you can factor. Alright, let's see. Factors of 36. Would be 3 and 12, right? 3 and 12. Alright, so that'd be negative 12 and positive 3. And then you split them up, and so you'd have x equals 12 and negative 3. Well, we've got to plug them in and make sure they work, so let's plug them in here. So it'd be negative 3 times negative 3 minus 9. That's negative 3 times negative 12, which is positive 36. And 6 to the second power is positive 36. All right, let's plug in, so negative 3 works. Let's plug in 12. So that's 12 times 3, which is positive 36. And 6 to the second power is positive 36. So that one works too. All right, number 7, you still have to get that base e by itself first. So you're going to subtract the 2 over, and so that would be 178. And then you're going to divide by 4, and that'll be, is that a decimal? 44 and a half, I believe. Okay, then you're going to do the natural log on both sides to get rid of the e. Those cancel. And let's plug it in our calculator, okay? Alright, so it was the natural log of 44.5. And so 3.7. Okay, let's see. That 8 is going to round that 4 up to a 5, which rounds this 5 up to a 6. So the 8 rounds the 4 up to a 5, and that 5 would round that 5 up to a 6. So it'd be 3.796. Because remember, we want 3 decimal places. All right, and last one on Math Workshop for today, number 8. We are going to, there's nothing to get away from the natural log, so we're just going to do the base E to get the natural log away from the 3x. And if you do it to one side, you got to do it to the other. So those cancel, leaving you with 3x equals e to the 8th. Divide by 3. And let's plug it in our calculator very, very carefully, okay? All right, so we do second natural log to get the e, and then e to the 8th, and hit enter. And then we divided it by 3. So it'd be 993.653. Sorry guys, I had to squeeze that last bit in there. 993.653 is what it should be, okay? All right, here's what we're going to do. We are going to do ACT prep. So go ahead and grab your ACT while I finish erasing this. And we're going to do 3 problems, which means we're going to have 3 minutes to work them out. All right, so we're going to do 35 through 37. Don't start yet, though. 35 through 37. All right, so if y'all can see that timer, we'll start at 7 minutes, okay? And we're going to do 35 through 37. All right, go ahead. 35 through 37, 3 minutes. All right, guys, time's up. Go ahead and put that in the safe spot. And let's grab your study guide and let's look at these problems, okay? Remember I told you that I was going to work out each one of these. A few of us in class on Friday worked out one, maybe two of these in class. So you can always just fast forward through that part if you would like, or you could watch it again, whatever you would like to do. Remember, if there's one that you are confused about, all you have to do is circle it or put a star by it. And when I get back Wednesday during zero period, you are welcome to come see me, and we will work out many more like it if you need to, okay? All you have to do is let me know and be here on time for zero period, okay? All right, so let's look at number one. Number one is one of those problems that has been giving many of us issues because of that a squared minus b squared. Just because they are letters, they work the exact same way. Those are the difference of two squares. So you factor that out as a plus b and a minus b. They're two squares being subtracted, so you split them up that way. All right, on the bottom, 2a minus 2b is a GCF of 2, which leaves you with a minus b. A minus b's cancel out because one's on top and one's on bottom, and you're multiplying, and that's your answer. All right, and if you're worried about restrictions, that one does not have a restriction because 2 can never be 0. All right, number 2, we're going to factor that one out. So that would be negative 6 minus 2 on the top. And that would be positive 4 minus 2 on the bottom. Because we're multiplying, and one binomial is on the top, and one binomial is on the bottom, those guys cancel out. And that would be your answer. And if you're worried about restrictions, the restriction would be x could not be negative 4, because if I plugged in negative 4, it would make the denominator become 0. All right, number 3, we're going to do GCFs on all of these. So we have y minus 3. 4 is the GCF on the bottom, which leaves me with 2y minus 1. 5 is the GCF on the top, which leaves me with 2y minus 1. 5 is also the GCF on the bottom, which leaves me with y minus 3. And you can't just go through here and just fly through and cancel stuff out, okay? First of all, you're multiplying. That's the only reason why you can cancel. Second of all, one binomial is on the top and one binomial is on the bottom. So the 2y minus 1s and the y minus 3s cancel. The 5s are two monomials, so they cancel. And your answer is not 4. The 4 is on the bottom of the fraction, which means it is 1 over 4. And 4 can never be 0, so you do not have a restriction. So just slow down and don't tell me the answer is 4, okay? All right, remember, if I'm going too fast, you can always just pause it or rewind it. Okay, number 4, that guy factors as x minus 3 and x plus 1. The bottom is the difference of two squares, so that's x plus 3, x minus 3. The top of the other one factors as x plus 2 and x plus 3 because I need them to multiply to be positive 6. 6 minus 1 is positive 5, but when I multiply 6 times negative 1, that gives me a negative 6, not a positive 6, okay? And then the bottom is the difference of two squares. All right, the only reason we can cancel is because we're multiplying. And when we cancel, one binomial has to be on the top and one binomial has to be on the bottom. It doesn't matter where they are, as long as one is on top and one is on bottom. So what I have left is x plus 2 over x minus 1. And if you're worried about a restriction, if I asked you to give me the restriction on the test, you would put x could not be 1, because that is where the bottom equals 0. All right, number 5. So on this guy, that's going to be x minus 8 and x plus 2. On the bottom, that would be x plus 7 and x minus 3. Now we're dividing this time. I don't want to divide. You want to change this division sign to be multiplication. But in order to do that, you have to flip this fraction, okay? So that'd be x squared minus 8x plus 15 on the top, and x squared plus 9x plus 14 on the bottom. All right, so the top factors as x minus 5 and x minus 3. And that guy factors as x plus 7 and x plus 2. All right, the only reason we can cancel is because we're multiplying. And then one binomial has to be on the top, and one binomial has to be on the bottom. Look at your plus 7s. They do not cancel. X plus 7 and x plus 7 do not cancel because they are both on the bottom, okay? The x minus 3s cancel because they're both on the top. So smush all that together. And that would leave you with x plus 7 squared on the bottom of that. And you could FOIL that if you wanted to, but we're just going to leave it alone. And if I asked you for a restriction, x could not be negative 7. All right, number 6, same thing. So let's factor the first one with a GCF of y, which leaves me with y minus 4. And on the bottom has a GCF of y, which leaves me with y plus 2. I'm going to change that division to be multiplication. And I'm going to flip this whole fraction right here. All right, so let's see. The bottom factors as y minus 4 and y minus 5. The top factors as, oh, I don't have enough room to squeeze that in, do I? Let's go squeeze it in right here. Y minus 5 and y plus 2. All right, so let's see. The y's cancel because they're two monomials. They only cancel because they're two monomials, okay? Can't go canceling y's just to cancel y's. Let's see. Y minus 4's cancel because one's on top, one's on bottom. Y minus 5's cancel because one's on top, one's on bottom. And the y plus 2's cancel because one's on top and one's on bottom. And when you divide things, they leave you with 1, not 0. For example, 5 divided by 5 is 1. 11 divided by 11 is 1. X plus 2 divided by x plus 2 is 1. They don't cancel and give you 0. They cancel and give you 1, okay? All right, let's keep going. All right, number 7, you've got a division again. You don't want division. You want multiplication. So let's factor the first guy. That'll be plus 3 and minus 2. Let's factor the bottom guy. That'd be minus 2 and minus 1. Change that division sign to multiplication. And let's flip this guy. All right, then we have a GCF of 5 on the top, which leaves me with x minus 1. And a GCF of 2 on the bottom, which leaves me with x minus 4. All right, let's see what we have. The x minus 2's cancel. The x minus 1's cancel. And then we want to put that 5 in the front. So it'd be 5x plus 3 over 2x minus 4. And you could leave it like that. Or you could distribute if you wanted to distribute. And if I asked you for a restriction, it would be x equals 4. All right, here we go. The ones that change the game are the addition and the subtraction. You cannot cancel anything with addition and subtraction until you get it all the way down to the bottom and you have factored and you've changed it to multiplication, okay? That's the only way you can cancel, so don't cancel anything. All right, so here we go. Number 8, the LCM, the least common multiple between 4 and 12 would be 12. All right, and then a to the third. So we've got to make all those fractions 12a to the third. All right, so to make 4 become 12, I multiply him by 3. And if I do it to the bottom, I have to do it to the top. And I have to put parentheses around my binomial. Okay, to make the a squared become a cubed, you multiply him by a. And if you do it to the bottom, you do it to the top. Okay, then we're going to make it one big fraction. You could go ahead and distribute if you wanted to. All right, so now I'm going to distribute, and I'm going to get 3a plus 18 plus 5a. over 12a cubed. And then I'm going to combine like terms. 3a plus 5a is 8a plus 18 over 12a cubed. All right, and now this numerator has a GCF of 2. So I'm going to bring that 2 out, which leaves me with 4a plus 9 over 12a cubed. Now you have two monomials. You have 2 is a monomial because there's only one term, and you have 12a cubed is a monomial because you only have one term. Those are smushed together. They're not added or subtracted together. So now you can cancel the 2 and the 12 and make the 12 a 6. So your answer would be 4a plus 9 over, let me write this where you can probably see it. Sorry. 4a plus 9 over 6a cubed. And you cannot cancel the a's because you have a binomial on the top and you have a monomial on the bottom. You cannot cancel monomials and binomials together. All right, and let's look at number 9. So before we get to doing anything with this guy, let's factor first. And that gives me a minus 2 and a plus 2 on the bottom. So that shows me that I need to multiply the second one by, did I say a? I meant x, sorry. By x minus 2. All right, let's make them one big fraction. Doesn't matter the order, as long as 1, 2 is positive and 1, 2 is negative. Doesn't matter the order you put them in. All right, let's distribute that 2. So give me 6 plus 2x minus 4 over x plus 2, x minus 2. I don't know why I just flipped the order around. Don't worry about it, it'll be okay. And then we're going to subtract the 6 and the 4 and get 2. And you could factor out a GCF of 2, but if you can see that nothing cancels, you can leave it alone, like this. Or you could factor it if you need to see it. And now you can definitely see that nothing cancels. So either one of these is correct. Either or is fine. Or, I mean, you could put it like this if you wanted to be, if you wanted to have everything factored back. I mean, it doesn't matter which one you put. I'll accept either one of those three best. If you wanted to do a restriction, then you would tell me x could not be plus and minus 2. Oh, back over here, I forgot to put my restriction on this one, didn't I? 8. You should have put that a could not be 0 was the only number. That would plug in and make the bottom 0. All right, here we go. Let's keep going on the same adding and subtracting stuff. This one's real similar to your math work. I mean, not your math workshop, your checkpoint that we've been doing. So you've got negative 28 and 3, so that would be positive 7 and negative 4, showing you that this second fraction needs an x minus 4, and if you put one on the bottom, you have to put one on the top. All right, let's smush it together and make it one big fraction. No, you cannot cancel the x minus 4s. Get it out of your head. Do not cancel them. Cannot cancel because you're adding, okay? All right, let's distribute that x. And so that gives me x squared plus 11x. Well, here, let me write this so y'all can see this. Let me do this differently. There. Let me keep it in order so I don't freak anybody out. All right, then we're going to combine the 11x and the 4. All right, once you make it all the way to the bottom, then you ask yourself if anything will factor, and you have a GCF of x on the top. now that you are multiplying your terms together on the top, instead of adding and subtracting your terms together on the top, now they will cancel. And so that gives you x over x minus 4 as your final answer. And if I asked you for a restriction, x could not be 4. All right, remember to circle or star the ones that you don't know how to do, okay? The ones that you're still a little weak on. All right, let's go ahead and factor these. Let's see, 11 factors as x minus 6 and x minus 3. This one factors as x minus 6 and x minus 4. So notice they've already have an x minus 6 in common. So this first guy needs an x minus 4, and if you put one on the bottom, you have to put one on the top to keep it equal. And now the second guy is missing an x minus 3, and if you put one on the bottom, you got to put one on the top. All right, let's push everything together. Make sure you bring that minus sign with that 4, okay? That was a lot of our issues on the checkpoint, was that minus sign. Okay, do not cancel the x minus 4s and the x minus 3s because you are subtracting those terms together. You're not multiplying, so you cannot cancel. All right, distribute the x, distribute the negative 4. So you get x squared minus 4x plus 12 over x minus 4, x minus 6, x minus 3. All right, combine like terms. Negative 4 and negative 4 do not cancel. You went to Walmart and you spent $4. You went to Target and you spent $4 more. You have spent $8. Keep your same denominator. All right, now that you have distributed everything, you've combined all your like terms, then you ask yourself if what you have left will factor. X squared minus 8x plus 12 will factor as x minus 6 and x, here let me do it on the next line, x minus 6 and x minus 2. Now that you are multiplying in the middle, the x minus 6's will cancel out. Hint, hint. Notice at the beginning that they had x minus 6 in common already. That's a good sign when they have something in common. So keep yourself aware that something will probably cancel in the end. Most of the time when they have something in common already, something will cancel in the end, okay? So just keep that little tidbit in your head. All right, now that will cancel. You could FOIL the bottom if you wanted to, but it's really easy to see a restriction when you keep it factored out. So you can't have x cannot be 4 or 3. Wherever the bottom cannot be 0 is where your restriction is. All right, I think we are, nope, we're not done with the first page yet. Let's keep going. All right, so now these are different because these have an equal sign. So you have to tell me the least common multiple. So number 12, the least common multiple would be 6x. And so you're going to multiply that 6x times all 3 of these guys. Now the reason this worked this way was because of this equal sign. The reason you cannot cross multiply is because you have this plus sign right there, okay? So you cannot cross multiply when you have a plus sign. All right, here we go. So I'm going to write the steps out. I know most of you don't need these by now, but I'm still going to write them out because there's still some people that need them. All right, so the 2 and the 6 will reduce by 2 to give me 3. So that leaves me with 3x over 1, which is 3x. The 6 and the 6 will cancel. Leaves me with x times x, which is x squared. The 6x times the 6x and the 6x will cancel, leaving me with 18. Because I have an x squared, I want to get everything to one side. so that I can factor. And that would be x plus 6 and x minus 3, which means that x could not be negative 6 and x could not be positive 3. The only place that you can plug it in to make sure that it does not make the denominator equal 0 is right here. Well, if I plug in negative 6, that gives me negative 36. That doesn't make it equal 0, so he's good. If I plug in 3, that gives me 18. That does not make the denominator equal 0, so he's also good. So I do not have an extraneous solution. Both of them work. All right, let's look at 13. 13, your least common multiple would be 2x. So you're going to distribute that 2x to all three of these guys. All right, I'm going to write the steps because I know some of us still need it, and there's nothing wrong with that. If you can skip these steps, go on with your bad self. All right, the first one, the x's cancel, leaving you with 1 times 2, which is 2 over 1, which is just 2. The second one, the 2's cancel, leaving you with x times x, which is x squared. And the last one, the 2x's cancel, leaving you with x plus 4. All right, so we're going to have the x squared in the front. We're going to subtract the x over. We're going to subtract the 4 over. And 2 minus 4 is negative 2. And then we're going to factor that as negative 2 and positive 1. And so x is 2 and x is negative 1. All right, so there's two places we could plug it in. We could plug them in here. Well, if I plug in 2, he's fine. If I plug in negative 1, he's fine. None of those make the bottom equal 0 in this place. Well, 2's never going to be 0. He's 2. Well, 2x, let's plug in 2. That gives me 4. So he's good in all spots. If I plug in negative 1, that's negative 2. And that means he's good in all spots. So we're good to go on both of them. Now, number 14. You're not adding or subtracting another fraction to either one of these fractions. So, if that makes any sense, because I said fractions like 5 different times in that same sentence. So, anyway, so if you notice, let's go back. If you notice, you're not adding two fractions together on 14 like you were on 12 and 13, okay? So, technically, you could just cross multiply if you wanted to. You'll get the same answer. And in fact, I'll work it both ways because I'm sure some of you already saw that. So you could either multiply it by x plus 4, x minus 1. And that leaves you with x times x minus 1 equals 3 times x plus 4, which if you cross multiply, then that just means you got to skip that first step and go straight there, okay? You get the same answer. All right, so let's distribute. Let's subtract the 3x, subtract the 12, and that factors, wait a minute, did I do that right? Minus 3, yeah, that's right. Sorry guys, I completely just blanked there for a minute. So it'd be minus 6 and positive 2. Good grief almighty. Can't think. And so that'll be x equals 6 and negative 2. Alright, so let's see if we can plug those in and make any of these 0 on the bottom. So if I plug in 6 here to this one, that'll be 6 plus 4, which is not 0. If I plug in 6 here, that'll be 6 minus 1, which is not 0. So 6 works. Alright, if I plug in negative 2 to the first fraction right here, that'll be negative 2 plus 4, which is not 0. And if I plug in negative 2 to the second one, that'll be negative 2 minus 1, which is also not 0. So they both work. All right, let's flip over to the back of the page and let's look at 15 and 16. All right, 15, notice that they already have a squared plus a minus 2 in common. So let's factor these out, and that'll be a plus 2 and a minus 2, or excuse me, and a minus 1. And this will be a plus 2 and a minus 1. Notice that they already have an a plus 2 in common. Remember what I told you earlier, if they have something in common already, we might be able to cancel at the very end, okay? So this middle guy needs an a minus 1. Well, if I put one on the bottom, you've got to put one on the top. Whoa, there's an equal sign. I don't know what I just did there. Scratch that. Don't look at that. That's not true, because there's an equal sign. Just kidding. We're going to multiply by the least common multiple. Did not even see that equal sign. So because we have an equal sign, we're going to multiply by the least common multiple, which is a plus 2 and a minus 1. And we're going to distribute that to all of these. So once again, I'm going to write these steps. Most of you don't need them anymore, but I'm still going to write them. All right, so the whole point of doing that was to make the fractions go away, so that way you can just distribute and combine like terms. Well, right off the bat, let's distribute the 3, or if you notice the 2's cancel, you can go ahead and cancel the 2's as well, okay, if you notice that. All right, so I'm going to subtract the 2 to both sides, so that leaves me 3a minus 3 equals 0, because I subtracted the 2's. Then we're going to add the 3. That gives me 3a equals 3. Divide, and a equals 1. But when I go to plug in a equals 1 right here and right here, it will make the denominator become 0. So this is an extraneous solution. Well, that's the only solution we had. So if that's the only solution we have and there's nothing left, then we say this is a no solution. All right, let's look at 16. 16, let's factor this, and that would be a minus 2 and a plus 1. Same thing as the other guy, just different signs. Factor this one, and that's a minus 2 and a plus 1. All right, let's multiply by our least common multiple, which is a minus 2 and a plus 1. Sorry, I don't have any more room, guys. And here we go. Let's multiply. Careful of your signs on this one with that negative 1. I would keep that 1 in front if I were you. That way you knew you wouldn't mess up and distribute that negative 1 incorrectly. Ooh, I'm going to squeeze this last one in. Hold on. Yeah, I did it. There we go. Okay, so let's distribute that negative 1. Let's combine like terms. So we're going to add the 2 and the 2 and give me 4. Let's add the 1a over and give me 4a. Now let's add that 8 over to the 4 and give me 12. And divide, and a is 3. And if I tried to plug in 3, here it would give me 1, here it would give me 4, there it would give me 4, 1 and 4. So none of them are 0, so that's my answer. That's my solution. Okay, last 4 are graphing. All right, so here we go. We're going to do graphing. Remember your cheat sheet? I think it was page 8 that it was on for horizontal asymptotes. So horizontal, you are looking at your degree. You have a degree of a 2 on the top and a 2 on the bottom. So when they have the same degree, you divide their coefficients. So the leading coefficient here is 1, leading coefficient here is 2. So to be at 1/2. All right, so we're going to go on our graph. And 1/2 is right in the middle between 0 and 1, which is kind of hard to keep even, but we're going to do the best we can. You not so hard, me a little bit harder on this board. All right, then we're going to factor, and we're going to hope something cancels so that we can look at a whole on our graph. Let's see. Ooh, this guy has a GCF on the bottom. Factor that out first before you slide divide bottoms up, okay? Factor the GCF out first. So now let's factor that. Don't forget your 2 in the front as x minus 2 and x minus 1. So nothing cancels, so I don't have a whole. But wherever the denominator equals 0, well, actually there was a place for a whole. Yeah, so on part C where it says whole, just put none or does not exist or something like that. Part B for a vertical asymptote is where the denominator equals 0. So if I were to set x minus 2 equal to 0, I would get x equals 2. If I were to set x minus 1 equal to 0, I would get x equals 1. So we're going to go on our graph. And we're going to draw on our vertical asymptotes at 2. And, ooh, Lord, those are real close together. Holy moly, that's going to be hard to draw. Did I factor that right? No. Good grief, y'all. Bear with me. I don't have y'all yelling at me telling me I did something wrong, so I got to catch my own mistakes. Hold on. Let's see. That'd be -2 and a +1. So that'd be a -1. There we go. That's better. Y'all probably getting a good laugh out of this. It'll be alright. I hear it when I get back. There we go. Okay, that is better. Now let's go to our calculator and let's type in our original graph right here, the original one. So go to y equals and clear it out if it's got something in there. Put parentheses around your binomial, and it was x squared minus 9 on the top. Close your parentheses. Divided by 2x squared hit the wrong button. Divided by 2x squared minus 2x minus 4. Then we'll hit graph. And we know we're going to get 3 pieces because we had the asymptotes the way we did. So let's go to our table. Let's see. We got an error at -1. That's how we can make sure you're not like your teacher and know how to factor. And then we should have another error at +2 because those are where our asymptotes are. Let's see, we've got -3, 0, 1, and 2. Those are good points we can put on here. All right, let's see what else we had. We had 0 and 2.25. That's a decent one. Let's see if we have anything else. Oh, 3, 0. That's a good one. There's a good one. 7 and 0.5. I think you got enough room for that one on your graph. It's not really at 0.5 because you had a horizontal asymptote there, but it's probably just so close that your calculator is rounding it, okay? So if some of y'all are asking, like, why in the world do we have a horizontal asymptote and a point there? It's really not. It's just that it's so close that your calculator is rounding it, okay? All right, so let's look back at our picture, and let's try to mimic what's happening. So let's see, it's going to ride right along here. As soon as it gets to that point that we put, it's going to round down and go down to negative infinity. All right, our other one kind of looked almost like a U between those 2 points right there. And then we're going to ride right along the half and curve down right there. Make sure you put arrows on the ends of your graphs, okay? All right, and that's all she wrote on that one. Let's look at 18. Remember, if I go too fast, you can always rewind it or pause it. All right, remember to put a star by something if you're getting confused somewhere, okay? All right, first things first. We have no x's on the top, but we have 2 x's on the bottom. So we have a bigger degree on the bottom, which always means we have a horizontal asymptote at y equals 0, which is basically just the x-axis. All right, then we're going to factor, although some of you can probably see it and not really need to factor. And you can see for part B, you have a vertical asymptote at x equals positive and negative 3. There's nothing wrong with putting 3 comma negative 3, okay? You can do that if you want to. Nothing canceled, so we don't have a hole. So for part C, you're just going to put none or does not exist or something of that effect. And then we're going to go back to our original equation and we're going to plug that into y equals. We don't have to put a parentheses around 3 because he's not a binomial, but we do have to put a parentheses around the x squared minus 9. And hit graph, and we know we're going to have 3 parts because of the way our asymptotes came out. And we're going to go to table, and we should see at 3 there's an error, and negative 3 there's an error. Okay? Alright, so negative 2 and negative 0.6 is a pretty decent number. That's almost negative a half. So we've got that at negative 2 and positive 2. So we're going to graph those. Negative 2 and negative 0.6 and positive 2 and negative 0.6. And that was our U-shaped picture, right? Make sure. Yep, that was our upside down U shape. All right, let's see if we can get something on the other side. Nope, this negative 4 and 0.4 is going to be the closest one. So negative 4 and basically a half, close enough. And then there was another one, positive 4 and basically a half. And that one rode right along here. As soon as it gets to that point, it curves. It's really hard to draw straight, especially when it's that close. This one rides right along here, and when it gets to this point, it curves and is really, really close to the x-axis. Okay, that's 18. All right, let's look at 19. Again, if I go too fast, all you have to do is pause it or rewind it. Okay, we only got 2 more left. Here we go, 19. All right, first things first. You have a degree of x to the 1 on the top. You have a degree of x to the 2 on the bottom. So for part A, your horizontal asymptote is going to be at y equals 0 because your biggest degree is on the bottom. For part B, for a vertical asymptote, we're going to have to factor. So the numerator has a GCF of 2, which leaves me with x plus 4. The denominator factors as x plus 4 and x minus 2. So we have a hole. Sorry, guys. We have a hole right there at x plus 4. Hold on. Let me zoom this back in. Okay, so our vertical asymptote is what we have left on the bottom, which is at x equals 2, and we have a hole at x equals -4, because if I were to set x plus 4 equal to 0, then x would become -4. Alright, so we're going to draw in our asymptotes. One on the x-axis is our horizontal one. And then our vertical one is just at 2. Well, since we only have one vertical one, that means we're only going to have 2 pieces to our graph instead of the 3 pieces that we've been having. And then for our hole, we're just going to have to wait and see where that graph hits -4 right here. So we're just going to have to wait and see what happens right there, okay? So let me see. Let me do a different color. 1, 2, 3. Right here. Don't make a mark or anything like that, but I'm just showing you whatever that graph crosses this line. Don't draw this line, but I'm just drawing it for visual. Wherever that graph crosses anywhere on this line, that's where the hole is going to be. So if it's way down here, it's going to be a hole here. If it's right here, it's going to be a hole there. If it's way up here, it's going to be a hole there, okay? So we're just going to have to wait and see where it crosses. So here we go. Let's go to our calculator and let's type it in. So we've got a binomial on the top, so we've got to use parentheses. And we've got a trinomial on the bottom, so we also have to use parentheses. Alright, see, you only got 2 pieces, okay? Alright, so let's go to our table. And let's see, we've got -2 and -0.5. That's a good one. We have 0 and -1. And we have 1 and -2. Those are all really good ones. If you look at -4, you're going to see you're going to have an error. It's okay. Let's see if we have any more on the other side. We have 3, 2, and 4, 1. Positive 4, 1. So that's not a hole there. That's a positive 4. And then let's see if we have one more. 6 and 0.5. Alright, those are all really good ones. So let's do the one on the right first. He curves and he curves. When he gets to those 3 points, he starts going down real close, but never touches. And if you look at the other side, you can see that he's going to go, I don't know if I hit this pin right. And curve, and he's curved right here at those 3 points. And when he gets to -4, there is going to be a hole right there at -4. And he's going to keep getting closer and closer and closer to the x-axis, like that. Obviously, yours is probably a little bit prettier than mine. But you get the gist of what's going on. There's a hole at -4. Alright, we got one more. 20. I'm sure the bell has already rung by now because it looks like this has taken a few minutes to do this, but it's okay. You can just look at the ones you need. Alright, so first things first, you have a horizontal asymptote at 1 because your degrees are the same. You have 2 and 2, so you divide their leading coefficients. So 1 over 1 is 1. Alright, so we have a horizontal asymptote at y equals 1. Alright, then we're going to factor. The top is the difference of 2 squares. The bottom factors as x plus 3 and x minus 1. Those cancel. So that means for part C, we have a hole at x equals positive 1. And what's left on the bottom would be where my vertical asymptote is, which is at -3. So I'm going to go to -3 and put my vertical asymptote. Alright, and we're going to go to our calculator to y equals, and we're going to clear it out. We're going to type in x squared minus 1 in parentheses, divided by x squared plus 2x minus 3 in parentheses. Make sure you're hitting the subtract 3, by the way, and not the -3. There is a difference. Alright, so we've got these two pieces. Let's go to our table. When we have two pieces, we have a lot better numbers. So we've got -1, 0, -2, -1. Let's see what else we had. -3 is an error because that is our asymptote. We've got -4, 3. And we've got -5, 2. Those are good ones. And our whole is at -3. Whole's at +1. I'm sorry. So let's see. It's going to go, 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 go. When he gets here, he's going to curve. And when I get to +1, I'm going to put a whole. And then I'm going to go, 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 go. Oh, don't go over. Don't go over the x-axis like that. And on the other side, and that's it. And that's all she wrote, ladies and gentlemen. That's all of them. Please let me know if you have any questions on Wednesday when I get back. Y'all have a great day.